All right, in section 3.5, we looked at analyzing arguments with Euler diagrams, okay? It was kind of an aside to what we've been doing. In this section, we're going to look at analyzing arguments with truth tables. And we've been talking about truth tables in sections 3.2, 3.3, and 3.4, especially 2.3.2 and 3.3, actually. So we're going to go back to truth tables here. So it has some familiarity in that sense, but I will tell you that it becomes more complicated than Euler diagrams are, because if you'll remember, truth tables can get really big, right? The more statements you have and things like that, the messier the truth table becomes. So we're going to see some of that happening. At the outset, there's a lot of writing. So let me just read it, and then you can write it, and then I'll push pause so that you can get the writing done. There's 4 steps that we have to do in order to test if an argument is valid with a truth table. The first thing is we have to take and we have to assign letters to represent each component. 2 is to express the premise and conclusion symbolically, right? Put ands and ors and all the connections together. The third statement is to form the symbolic statement of the entire argument by writing it all combined together. And then step 4 is to complete the truth table and analyze the argument afterwards. Okay, so I'm going to be quiet and let you copy those pieces down. All right, sorry, I know it's a lot of writing. It'll be helpful when you get to filling all the details in on example number 3, I think it is. The first couple of examples are partially done in this process. Okay, so if we take a look at example number 1. In example number 1, I want to focus on step number 4. All right, step numbers 1, 2, and 3, or step numbers 1 and 2 specifically are already done for us. It's already in symbols, and it's already written in the sort of the format we saw in section 3.5, right? We saw these 2 statements, a line, and a third statement, okay? So I want to show you how to do steps 3 and 4 on this one. So in step 3, what we're doing is we're taking both of the premises, so those are the first pieces above the line. So I have tilde P, arrow Q, and I'm joining them with an and statement with the second premise, P, because it just says P. And I'm putting all of this together as the premise of a conditional with the result tilde Q at the end. Okay, so literally what I do is I take each of these pieces and I join them with and, all right? And then I do an arrow for the line and it ends here at tilde Q. That's how you put it together, because that's what statement 3 or step 3 is telling you to do. And then what we do is we create a truth table for this kind of cumbersome long piece that we just created. Okay, so how many statements do we have? 2 statements. So my truth table is going to have 2 columns. P and Q. That's where we start. After that, we start with inside the parentheses and work our way out. It might be helpful right now to go ahead and recognize that we have a tilde Q coming and a tilde P coming. If you want to put them both in here, it's sort of in order at this point, you can. If you want to wait and put the tilde Q at the end because we don't need it for a while, at the end you can do that too. I usually tend to wait if I don't need it right away. Luke?
How do you know to put the and in there?
That's actually what it said in step 3.
Oh, it is.
Yep, step 3 says to form a symbolic statement of the entire argument by writing the conjunction, that was supposed to be a highlighter, the conjunction, that's an and statement of all the premises. That's how we know. Okay? Got it, Caden? Okay. All right, so we've got P, we've got Q. I need the tilde P at the beginning. It's inside of the parentheses of one of the initial statements. So I'm going to put my tilde P right here. If you want to do your tilde Q next, you may. I'm going to wait. So working from the inside out with my statement, I'm going to move it down a little so I can point to it on the screen. I want to do this piece. I have the tilde P now because I made a column header for it. I already had a Q, so I can do the if-then statement for this one next. So I have tilde P implies Q, and that's going to be my next one. Now, the next piece of the bracketed part is the piece on the outside here of the original parentheses. So I'm going to join my part that's in parentheses that I just created a column for with an and statement and P. So it's like in algebra. My kids are working in algebra right now. I have 3 children in my house in Algebra 1. And we keep talking about how we do something inside the parentheses and we just work our way out. It's just the same with logic arguments. We start with the inside of the parentheses and we work our way out. Okay? So we're working our way out. I now have a column that should say tilde P, arrow Q. That's the column I just did, with an and statement with P. Now that's everything inside of my brackets now. I've done everything in brackets. Okay, so everything in brackets is done. I now have an arrow and I have a tilde Q. So if you already wrote tilde Q, then you don't have to write it again, but I didn't. So I need a tilde Q column to happen. So I'm going to put that in here now. Whoops. Can't do it right. Hang on. There we go. So I have my tilde Q column. So the part here is in brackets. The tilde Q is the part that's after my arrow. So the last thing to do is to string it all together now in my last column header. So my last column header is going to be the entire statement. It's going to have a bracket, parenthesis, tilde P, arrow Q, and P, in bracket, arrow, tilde Q. So the last column header will always be the entire statement that we're trying to work towards. That's what it's going to look like, the last column header. Okay? So this is what it looks like to set up the columns in step 4. And then the other part of step 4, there's 2 more parts actually. The next part of step 4 is to fill in the truth table. Now you know how the truth table starts. What's column P say?
True, true, false, false.
Right. True, true, false, false. And we know what column Q says. What does it say?
True, false, true, false.
True, false, true, false. And once again, if you have lined paper here, it's easier to work with this for your homework and so forth because you can keep the lines a little bit more straight than I will be able to. All right, tilde P. What's the tilde P column going to be?
False, false, false.
Right, false, false, true, true. Wonderful. I'm going to use highlighters like I have in the past. We're going to take column tilde P, and we're going to do an arrow over here to column Q. Now, it's been 5 days since we've talked about implications. So as a reminder, anytime an implication, that's the arrow statement, starts out false, it's automatically true. I'm not going to go through again all the whys on that. We did that before. But these first 2 rows start out false, so they're going to give it, no matter what happens, they're going to give us a true statement. So these are both true. The next possibility is that if it starts out true and it ends true, then it's true. So this third one's also true. The last one is the only time an implication, if-then statement is false. If it starts true, ends false, that's a false statement. Okay? My next column says I'm supposed to join the column I just created. A lot of times it goes back to the column I just created, right? The column I just created with the column P at the very beginning, and I'm joining them with an and statement. What is an and? When is an and statement true? When they're both true. So on row 1 and row 2, they're both true truths. So these are both true statements. But rows 3 and 4, sorry, I don't know where that F went. That should say false. Row 3 and 4 both have false statements in my P column. So since it's an and statement, that's enough to make the result false. Now I have a tilde Q column. What will tilde Q look like?
False, true,
False, true. Going back to my Q column and reversing things. And then my last column takes the previous 2 columns and it does an implication between them. So the first row says true, false. That's false. The next row says true, true.
True.
That's true. Then I have false, false.
True.
That's true. And I have false, true. That's true. Third thing to do in step 4 is to look at the truth table's last column and ask yourself, is it a tautology? Now, we didn't do a lot with tautologies, but we did talk about what they are. A tautology means that I have a true statement in every location on the last column, and I simply don't here, right? So if I do not have a tautology, then I have an invalid argument. If I do have a tautology, I have a valid argument. Now, I know it doesn't really make a lot of sense with this one because it put P's and Q's in everything and they don't have context. So I get that we don't have context. I just want to work on the logistics of how we go about doing it on this one. Are you okay with that? All right. Now, the next example also doesn't have context, but it's strung together for you, which means it's got steps 1, 2, and 3 already done. The only thing we have to do is step 4, which is the creation of the truth table and analyzing it at the end. So, how many statements do I have? 3. And that makes it harder, right? And I'm actually going to need quite a bit of space, so I'm going to use my entire screen and go over into this column over here. So, I have 3 statements, so I'm going to have 3 columns. I'm going to have P, Q, and R. The good news is there's no tildes, so I don't have any columns with tildes on this one to worry with. So I'm going to start inside the first set of parentheses. What does it say? If P, then Q, or P arrow Q, right. So we have a P implies Q statement. Now, I can't join that with anything yet because the thing I'm supposed to join it with is another set of parentheses, so I need that as well. The next set of parentheses I'll need now is going to be the Q implies R statement. Then what?
The P implies Q and the Q implies R.
Right, so I'm going to join those 2 statements together. Whoops, try that again. With an and connective. In other words, it's everything that's in brackets now. Okay, so everything in brackets has been done, but I can't go to the arrow now because I've got something else on the other side that has parentheses that needs to be done. So I need to do that part next. So that's the P arrow R. So everything before the arrow, the outer arrow has been done, and everything after the outer arrow has been done. Now I'm ready to put it all together. The entire statement will go as the header for my last column. So I have P implies Q and Q implies R. All of that implies that P implies R. And after we do all of this, I'm going to give you context because you've seen this argument a lot. You just don't realize it right now because I haven't given you any context. So, what goes in my P column?
True.
4 trues, yep. And then 4 falses. Lovely. What goes in my Q column? Yeah, they pair up. They go 2 trues, 2 falses, and then they do that again. So true, true, false, false, true, true, false, false. And then how about my R column?
True, false, true.
Hey, Jordan. You take those with you. Yep. Okay, true, false, oops. And then true, false, true, false. Okay, looks good? We get those for free. They're like that every time. Now I'm going to start considering columns sort of jointly, right? Everything's a little bit too long, so let's take this and change that. Oh, I can't do that one because that's actually part of my screen. That's all right. Okay, so I need to do P implies R. I'm sorry, P implies Q. So this is the implication right here. I'm struggling with my touching my screen too much today. There we go. All right, so P implies Q means that if I have the first two say true, 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 those two statements are true. The next two are identical, and they say true implies false. Those are false statements. The last four, all start out false. So they're all automatically true.
So can you repeat that one more time, that if they start out false, they're automatically true?
Correct, always. Yes, and we did that in section 3. 3.3, we looked at how that worked. So if a statement starts out false on an implication, right, an if-then statement, it is automatically true. Okay, so that's the first one. The next implication takes Q. Oops. Oh, my word. Get the whole screen here. That's what I wanted to do. Okay, and I want to do Q implies R. So I'm going to go between these two now. So the first one is true implies true. That's true. The next one's true implies false. False. I have false implies true.
True.
False implies false.
True.
Okay. I have true implies true.
True.
True implies false. False. False implies true.
True.
And false implies true.
True.
Or sorry, false implies false at the end is true. Yeah, there we go. Okay, now I'm going to join those previous columns that I just created with the word and. So this one and this one get joined. When is an and statement true? When they're both true. So row 1 is true and true. That's true. Row 2 is true and false. Row 3 is false and true. Row, I don't know what I'm on, 5 is 4, whatever. False implies, or false and true. False. I have true and true. Row 6 is true and false. Row 7, true and true. And then the last one's also true and true. Cool. Now we're ready for P implies R. So I'm going to be going between the first column and the third column. So this one to this one. And my statement needs to go all the way over here like that. So the first one is true implies true. True. Then I have true implies false. False. True implies true. And then true implies false. False. And then the last 4 statements all start out false, so they're all true. So feel free to go one line at a time, or feel free to take them in bulk if you start to notice things like that. We've done both. And then our last thing that we're supposed to do is to do an implication for those last 2 columns. So I'm supposed to be looking at this column implying this column. Going like this. So the first one is true implies true. And then I have false implies false. False implies true. False implies false. True implies true. False implies true. True implies true. And true implies true. Okay, so we're done with the argument. With the truth table, we've done it all. We're going to analyze it. What do you notice? We finally have a tautology, our first one. We haven't done one in class till now. Finally have a tautology, which means that this argument is valid. And I'll give you an example of where you've seen this before. All right. So, if A equals B and B equals C, then A equals C. You with me? Yeah. It's an equality statement. If one thing is equal to the next and then that one's equal to something else, then the first one's equal to the third one. You've seen it before, and you've seen it in all kinds of arguments besides just sort of a mathematical equality thing, okay? We use this all the time. Okay, let's do another one. This one's just all together, and it's kind of funny, okay? It's really long. So here's our statement. If I were a woman and you were my man, then I'd never stop loving you. I've stopped loving you. Therefore, I am not a woman or you are not my man. So it's kind of funny, right? But it's also really wordy, isn't it? It is. And we've got statements that are both in the affirmative, like it says, if I were a woman, and then later it says, if I'm not a woman. So we've got the affirmative and we've got a negation, right? Those are negations of each other. So we've got some negations involved. But the kicker is that we got to start with everything that's here and figure out what's going on with P's and Q's and R's and however many of them we need. So first, can you figure out how many statements we have? What are the statements you see? Somebody tell me a statement.
If I were a woman.
I were a woman. That's one of my statements. So I'm going to actually piece this together as we go. This one is one statement. We'll call it P.
I'm gonna say there's three.
Okay, what's another statement you see then, Luke?
You were my man,
You were my man. That's another statement.
and then I never stopped loving you.
Yep. And there's my third one. I'd never stop loving you. And you can either use that as R, or you could say it's tilde R if you like the fact that there's an R, there's a negation, there's this is not inside of it. So if you wanted to do tilde R, you could. I'm just going to call it R, and we'll deal with it later. But those are my three statements. So this one first says, if I were a woman and you were my man. And means I actually have the symbol like that, right? Okay. So at the very beginning, it says, if I were a woman and you were my man. That's P and Q. But it also has an if at the beginning, and it says, then something, right? So then what? Well, then R. And I never stop loving you. So this is one statement at the beginning. If I were a woman and you were my man, then I'd never stop loving you. And then it says, I stopped. I stopped loving you. So that's R. Yes, the negation of R, from the way we did it, correct. That's the negation of R. And I've got an and statement there. These are two statements that are both true. So this is like line 1, right? And this is like line 2, and we've joined them with and. I'm just writing it long instead of, blocked down like old style addition, okay? Now, after those pieces are done, we'll do that. We're joining them together because it says, therefore, that's that line. Yep, Julia? We joined them with and because they're the two pieces of statements that we're starting with. Okay? It's like doing this one right here. I've got line 1, I've got line 2, and I've got both things that are happening at the same time. It's the and. Yes. Okay, all that is supposed to imply, right? Therefore, that's my line, my implication. Therefore, one of the next things is going to happen. It says, therefore, I am not a woman. I'm going to do tilde P there. It says, or, that's V, you are not my man. Tilde Q. Look at all those tildes. Whew, my goodness. All right, you ready to put it all together? Okay, it's kind of messy. We're going to put it all together. We can do it. I know we can. I might not have enough space, so I might need to move my statement up to the top. I think I'll do that. I'm going to put this up here. All right, so we have P, Q, and R. This one's headers are really long, P, Q, and R. What would we have next? What do we have? What'd you say?
Oh, I skipped them.
That's okay. P and Q, I actually kind of have some parentheses look funny, but that's okay. So P and Q would be next. And then what? The P and Q implies R. P and Q implies R. Then what? Tilde R. That's the next part. Then what? You guys are doing good. Everything in the brackets, yeah. And if you wish, they're the only brackets here, right, on my screen. So just for the sake of space, because my screen's going to run out of space pretty quickly, I'm just going to put brackets. In fact, we could even put brackets and call it like number 1 and say that this thing right here, all of it is number 1 if it helps, something like that. I need more space. I don't have enough. I'm going to run out. So this is the bracket part. Okay, then what?
Then the other parentheses would not be.
Yeah, I need the other parentheses, the not P or Q, but I need the tilde columns for it first, right? Not P, and I need a not Q. And then, yes, I agree with you, Dylan. We need one that joins them together with the or statement. So I have tilde P or tilde Q. And then what? The entire thing. So again, I'm going to abbreviate that because I'm running out of space, and I'm just going to say all of it. It's a terribly appropriate column header, don't you think? It works. We'll go with it. Okay, it's all of it at the end. All right, so let's put this all together. This is our last big truth table. Everything else we're doing today is going to be much quicker, okay? Last big go at it, so bear with me. 4 truths, 4 falses. Pairs, I do true, true, false, false, true, true, false, false. And the next one we oscillate. True, false, true, false, true, false, true, false. P and Q, when's an and statement true? When they're both true. As I do my highlighting this time, I'm not going to delete them because I can only delete them if I can grab things to delete the highlighting, and I'm out of space to do that. So I'm going to use double highlighting this time. So this is going to look like this. So P and Q is going to be my yellow highlighting. Okay, so on row 1 and row 2, they're both true. Row 3 and 4 both have false in the Q column. So those are false. And rows 5 through 8 are all false in my P column. So those are also all false. Okay, all good? So I'm kind of clumping them together. Feel free to do them one at a time if that's easier or more useful for you. The next column says that I need to do P and Q. That's the column I just did, arrowing back to column R. So I'm going to change my highlighter. We'll do pink. We'll see how pink it shows up. Kind of whitish pink. And we're going backwards. Okay, so an implication is true if it's true, true, or if it starts out false. So the first one is true, true, so it's true. The second one is true, false, so that's false. The third, fourth, fifth, all the way down, right, from 3 down to 8, all start out false, so they're all true. Lots of truths. Lots of truths. Tilde R, we like this column. Tilde R. Somebody tell me what tilde R is going to do. Yep. False, true, all the way down. Oops. Okay, it's still working. False, true, false, true, false, true. I should really change my slides so that I have lined backgrounds on these. I really need to do that. Maybe next time. Okay. Number 1. Number 1 is the and statement that takes, and I'll highlight them and change again. Let's go with let's go blue. Column P, arrow Q. I'm sorry, P and Q, arrow R, implies R. That's what number 1 says. I'm not implies, and R. And these are true when both are true, right? True when both are true. The first line is true and false. So that one's false. The second one is false and true, so that's also false. The third one is true and false, so that one's false. Finally, row, whatever on, 4, I have true and true, so that's true. True, false is false. True, true is true. True, false is false. True, true is true. Tilde P, tilde Q. Those columns are quite quick. Tilde P reverses, so I have false, false, true. I'm sorry, 4 falses. False, false, and true, 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 and true. For the tilde Q column, I have false, false, true, true, false, false, true, true. And I'm doing an OR statement. We haven't done an OR statement at all today, I don't think. When is an OR statement true? When either one of them are true. So now I'm highlighting in green. Told you I was going to use a lot of colors. All right, so we've got my OR statement. It's true as long as there's any truth to it at all. So the first 2 are false falses, so those are going to stay false. The next one's false true and false true, so those are both true. And then the last 4, they all have true in the tilde P column, so they're all true on those 4. And then all of it. Okay, so all of it takes, let's try red. See if it's bold enough. Takes what I did over here. Well, that's kind of ugly looking, but that's okay. This column right here that I highlighted and called number 1, and the column that I just created here at the end, and I'm doing an if-then statement all the way across there. So the an implication is true when it starts out false. So there's 3 of them that start out false, so those are all true. True, true, true. And then I have a true statement in row 4 and a true statement at the implication's end, so that one's also true. Next, it starts out false, so that's automatically true. And then on I'm on row 5, I've got true implies true, so that's true. And then I have false, so that's automatically true. And the last one is true implies true, so that one would be true. All that work, and what did we find out? It's valid. Yeah, this is a tautology. Therefore, I have a valid argument, and I have nowhere to write valid at the bottom, so I'll write it up here at the top. This argument's valid. Okay. Last thing on this list. So I'm going to tell you or talk to you about what's in this chart, okay? And then I'm going to push pause, and I'm going to send you the rest of it I'm going to post this. I'm going to tell you watch the next 10 minutes or whatever it is because I want to make sure I talk to you about the test, and I want that 5 minutes to do that, okay? There are valid argument forms, and these are 4 valid argument forms and 2 invalid argument forms. So here's the cool thing. If you can identify that something is in one of these forms, you automatically know that it's valid or it's invalid without an Euler diagram and without a truth table. Folks, this is good news. I mean, because I'll tell you what, it was not fun. Let's be real. It was really messy and it's very complicated, and how easy is it to make one little mistake that makes it all mess up? Really easy. It really is. So these over here are really good news. If you put them in the right forms, right, if they fit one of these forms, I should say, then you automatically know if it works or not. And this last one on the top row, reasoning by transitivity, was our example number 2. Our example number 2 was this one, reasoning by transitivity, the one that says A equals B, if A equals B and B equals C, then A equals C. That's reasoning by transitivity. Okay, so we get these almost for free, not exactly, but if they fit in one of these forms, we do. All right, so you have to make sure that the forms work. There's one thing I want to add in here because sometimes people get a little confused on this one. The disjunctive syllogism, this one right here, let me use a different color here. It actually works also, so make yourself a note on this being also true. It also works if you have P or Q and you know tilde Q, and it would imply P. So it sort of has a similar statement that's also in that category. So if it fits that description, it actually is also disjunctive syllogism. Okay? So there's two versions of, that's the word I wanted for. It's two versions of the same argument. They're both disjunctive syllogism. Okay, so I'm going to push pause right here. I'm not going to do any examples of this. I'm going to tell you in a message inside of Canvas, start at this time. The time's going to say like 35 minutes in. And you can look at the last two examples. It'll only take me about 7 minutes or so to finish them, okay? All right, our last couple of examples, what we're going to do is we're going to take the arguments that were given over here, and we're going to put them into symbolic form. And then we're going to see if we can identify which one of the forms on the previous slide, right, the valid and invalid argument forms, it matches. That's going to be our goal. So take a look. It says, if she buys another pair of shoes, her closet will overflow. Her closet will overflow. Therefore, she buys another pair of shoes. So the two different descriptions we have going on here, right, statements that we have going on there, are she buys another pair of shoes and her closet will overflow, right? Nothing else is present. There's no other descriptions going on. So she buys another pair of shoes could be my P statement, and her closet overflows can be my Q statement. This is an implication. If she buys another pair of shoes, then her closet will overflow. So this is P arrow Q, right? Like this. The next statement says her closet will overflow. Whoops, sorry, I wrote down wrong. Her closet overflowing was what we called Q. So this line is Q. And then we have a therefore statement, right? And then it says she buys another pair of shoes. Well, she buys another pair of shoes was P. So this statement is P, or this argument says P arrow Q, then it says Q, and then it says P at the bottom. And if we take a look back, this one actually is exactly the second column over here. P arrow Q, Q, P. It is a fallacy of the converse. But do notice, it's very, very similar to this one right here, which is a valid argument with modus ponens. So you want to be really, really careful that you get your symbols and that you carefully look at what you have. We have the one that's circled in red, P arrow Q, Q, P. This is a fallacy of the converse. So this one is an invalid argument by fallacy of the converse. Okay? Second example. If Kerry Wood pitches, the Cubs win. The Cubs do not win. Therefore, Kerry Wood does not pitch. So again, we have two statements. This says Kerry Wood pitches, that can be P. The Cubs win, that can be Q. The first one is an if-then statement. So this is P implies Q. Statement number 2 says the Cubs do not win. So if Q is the Cubs win, then tilde Q would be the Cubs do not win. Whoops, that's not minus. Tilde Q, there we go. And then my therefore statement, right? Therefore, it says Kerry Wood does not pitch. So Kerry Wood pitching is P, so Kerry Wood not pitching would be tilde P. So we need to look over here at things that have some negations in them, right? So let me cut the pictures off of here. I want one that says P arrow Q. So notice what it eliminates, right? It eliminates this one. It's not this one because that one doesn't have P arrow Q. All the other ones start with P arrow Q. Then it has something about a negation. So it eliminates everything that doesn't have a negation. That's these. And I'm down to the last two that have a negation. But I want my negation to be negation of Q. Modus tollens has negation of Q. Fallacy of the inverse has negation of P. So this is the one that matches mine. So therefore, I have a valid argument. And the valid argument form is modus tollens.